this h, like we did before. And so based on where I put the A, the B, and the C, across from angle A is side A, across from angle C is C, and across from angle B is this whole thing. Okay. But like I talked about over here, when you draw the altitude in, it splits up the 7, right? And into pieces that we're not exactly sure of how it splits it up. So in this picture, when I draw the altitude in, this is side length B, but it's being split into 2 pieces. Okay? And if I want to do anything with right triangles, I have to know those 2 pieces. So what I'm going to do is I'm going to call one of them x, and then that's going to make the other one b minus x. For example, if this was 10, and this came out to be 7, you guys know that this part is 3 because 10 minus 7 is 3, right? So that's how I'm just setting it up. So then what I'm going to do is I'm going to write down some things that I know, okay? From this left triangle, okay, I know that x squared plus h squared equals c squared. Is that okay with everybody? That's using the Pythagorean theorem. It's not very helpful on its own, but we'll see how it gets put together. So c squared is equal to x squared plus h squared. Remember, my goal in writing the formulas is to give somebody something that they don't have to draw in all this stuff and split this stuff up. So what I want to do is gather enough information that I can then substitute or do whatever I have to do to give them a formula that only has in it angle A's, B's, and C's or side length A's, B's, and C's, okay? So this is a fine start, but I really don't want these 2 things in here because I don't want someone to have to draw x and to draw h. So I want other things that I can then exchange for x and h that only depend on A, B, and C, okay? So like we did with law of sines, one equation I can write is, in this case, I'm going to use the cosine. So the cosine of angle A would be equal to what in this little right triangle? The cosine of angle A would be equal to x over c. Okay? All right. So there's some stuff from that information, right? Now I'm going to go over to this little triangle and try to do the same thing. So I'm going to start with the Pythagorean theorem here. Okay? So this one would say that a squared is equal to h squared plus b minus x squared. Is that okay with everybody? So I kind of like, okay, I see this, none of them help me. I'm going to go over here and kind of look at the same relationships. Okay? I'm going to go ahead and multiply out this b minus x squared. So remember what that means. That means b minus x times b minus x. So for those of you that struggle with that, think about foiling that and what it looks like. Okay, so that's what it looks like when I multiply it out, which looks like a pain in the butt. But the reason that I like it is because then it kind of separates. I have something that's only based on b, and then I have stuff that still has x in it, which I'm not happy about, right? Remember my end goal. My end goal, if I'm trying to create a formula for someone, is that it only has side A, B, and C or angle A, B, and C. So you guys can look at a triangle and just plug stuff in without having to draw and separate and do all these extra steps. Okay? So I'm going to go ahead and rewrite what I just multiplied out for you guys. So this guy, when it got expanded out, was b squared minus 2bx plus x squared. If this is going to be a formula, I need the h squared to go, I need the x squared to go, and I need the x to go. Okay? That's essentially what I need to happen. Okay? So there's a couple of things I have over here that could help me. Okay? So for example, I could rewrite this in terms of h squared. In other words, if I got the h squared by itself, okay, the c squared is already on the other side, and then for the x squared to go to the other side, I would have to subtract it over. Okay? Is that okay with everybody? So I took something I wrote, I just rearranged it. Why would I do that? I would do that so that anywhere I see h squared now, I can take h out of the equation, and instead I can replace it with things that are based on c and x. Okay? Why would that even be helpful? Well, I only want a's, b's, and c's in the end. And this one right now has a mix of h's and x's that are unwanted. At least if I change them all to x's, I've gotten rid of the h's, right? Okay, so the first thing I'm going to do is get rid of the h's in the equation. by changing h squared to c squared minus x squared. So right here where it says h squared, I'm going to take that out, and I'm going to change it to c squared minus x squared. Okay? But I'm going to keep everything else around there the same. All right, so it looks super messy. Okay, can we do anything on the right side? It's the right side that looks super messy and has the extra stuff going on. Is there anything that simplifies on the right side? Yeah, x squared. This actually worked out beautifully, right? Not only did we take out one of the extra letters that we didn't want, the h, okay, but now that we've replaced it with this negative x squared and this positive x squared later on are like terms, and they're going to add up to 0 or cancel each other out. Okay? So that changes my formula to look like this. So remember, if my goal is to create for you a formula where you don't have to draw the altitude and calculate the height and these separate things, I only want A's, B's, and C's, either angles or sides. What's the only thing in my formula right now then that's unwanted? So here's my formula so far. What isn't a piece of the triangle that's given to you? X. Okay? So I want something that takes out x. Now, I could go back to here, but this had everything squared, right? I don't really want to get into square roots. So that's where this is going to help us. Okay? There's an x in this. I'm going to rewrite this formula much like we did for the law of sine so that x is by itself. In other words, I'm going to multiply both sides by c. And when that c cancels out, I get this formula that says x is equal to, and on this side, side c times the cosine of angle A. Okay. That means in this formula, I can replace x with side c times the cosine of A. I know it looks more complicated, but remember the goal. The goal is to get things that only depend on A, B, and C. So now I have a formula. It's not a pretty looking formula, okay? But it only involves sides and angles of the original triangle. Do you guys see? Everything you would plug into a space in that formula is either a little a, little b, little c, like a side from the triangle, or an angle A, angle B, angle C. This is one of the law of cosines, okay? So here's the trade-off. Law of cosines is only useful in these situations where you already know you have a triangle. So the good news is you're only using these in situations where you don't have to do all that stuff at the beginning to decide if there's no triangle, one triangle, or two. The bad news is it's definitely not as pretty or as easy to remember as the law of sines, right? Okay? It looks like this. So you can do this. You can drop an altitude like this from here and redo all the stuff that we just did. But every time you get a new formula, but the formula fits this pattern. So on the next page, we're going to summarize the formulas, okay? So this is where it's important for all of you to write something down. Okay, so what do our laws say? So the law that we just looked at, the one we developed, said that a squared was equal to, and then did you guys notice what came after that? So a squared is equal to, look at this chunk. So here's how I remember it. The first part of it kind of looks like the Pythagorean Theorem, but it plays mix and match with the letters, right? Like the order's not as important as Pythagorean Theorem. Whatever letter's here, the other two are here, but the setup's kind of the same. Something squared plus something squared. So when I remember it, I know they say one side squared equals the other two. Okay? And it doesn't matter if you say c squared plus b squared or b squared plus c squared. Those are the same thing. And then after that, it subtracts something. Okay? Look at what it subtracts. It subtracts 2 times. Notice the same 2 sides that you're using on this side of the formula. Okay? So A was over here, so B and C were over here, and B and C show up again. Okay? And then it has the cosine of an angle, but which angle? A, the one that was on the other side, so the one across from that side. So side across from that angle. Other sides fill in all the other stuff. Okay? So of course there's 3 versions of it because of the mix and matching of the letters, but again, so if I did redo all the work I just did, but draw the altitude somewhere else in the triangle, I would come up with a different version of this formula, okay? So there's another version that says b squared equals. Can anybody guess, following the pattern of what's here, what this side looks like for the b squared formula. John? Mm-hmm. Good. Okay. All right, so who thinks they can tell me what the third version is if we're using triangle ABC, and those are our letters? Mikey?
C squared equals A squared plus B squared minus 2AB times cosine C.
Good. So again, like the law of sines, it's not really about memorizing A's, B's, and C's. It's more about just seeing the structure, right, and whatever is going to help you remember that. Okay? So why is this useful? This one might actually be more useful than the law of sines, right? Every time we were using the law of sines, there was a way for you to draw the perpendicular and go through that. We just saw that we could not solve this using the law of sines. And if we did draw an altitude, we would be stuck as well, unless we set up like a system of equations. So this equation is going to help you fix that, okay? But then the question is, how do you plug things in and properly solve? Because sometimes we struggle with that a little bit. Okay, so then that's where looking at the examples will help us. Does everybody have the formulas written down? And remember, don't get bogged down in A's, B, and C's. They could have a triangle with X, Y's, and Z's, right? But you know that the side lengths are going to go here. Okay, and whatever side length is on this side, this is going to be the angle across from it. And the two that show up here again. Okay, that's kind of, we just want to know the structure of the formula. All right, so here is our scenario. Okay, we want to find side C. If we have side length A, side length B, and angle C. Now, you know today that we're learning the law of sines, or cosines. But when we come in on Monday, we're just going to be working with triangles, okay? And we're going to know we have all these tools. That's why I've been trying to emphasize to you guys to really check the situation that you're in. Because if you have a right triangle, we shouldn't be using the law of sine. I mean, we can if we wanted to, but we know stuff from regular geometry about right triangles, right? So when you look at this, what pattern of information do we have? Are we in the angle side-side situation? Here's how you would check it. Do you have an angle? Yes. Do you have the side across from that angle? No. Okay? Which means you have the two sides that are right next to it. So what situation are you in? Side angle side. Okay? So can we for sure build a triangle? Yes, because we can make that third side exactly the length we need to finish off the triangle based on what they give us. So we know for sure there's a triangle, so I'm just going to draw a generic one. I'm going to call stuff A, B, and C. Angle C is 34, length A is 15, and side length B is 18. Okay. So, can I use law of sines? I'm sure you like it better, but we can't use it, right? We don't have any of those angles and sides across from them, so it's not going to work for us. Okay? In this situation, could you draw an altitude and figure out information? You actually could. If I drew it right here, I would have a right triangle where I have enough to figure out how much of this is here, how much of this is here. Once I find out how much of 18 is right here, I would know on the other side how much is here, okay? And I would be able to fill in some of that other stuff, okay? We're going to practice using the law of cosines because we saw there are situations where we can't, okay? We specifically want to find side length C in this case, okay? So we want to use, all the formulas use all three, they have all three sides somewhere in them every time, right? But then they only have one angle. If this is the only given angle, it's probably a good idea to try to use that one, which means at the end of my formula, I want the angle that I'm taking the cosine of to be angle 34, which that was, in this problem, angle C, which means which side length is on the other side of my formula by itself? C, okay? And that means A and B are the two side lengths that look like Pythagorean Theorem-ish here, and multiply the 2 and the cosine right there. Oops, that should say A. Okay. So C is what I'm looking for, so that works out kind of conveniently. And then I would just plug in side lengths A and B for these measurements. So 15 squared plus 18 squared minus 2 times 15 times 18. And in this case, we would punch all that into the calculator because it's all on one side of the formula, right? So we don't really have to get anything alone there. Okay, so 15 squared plus 18 squared Yeah, it doesn't matter the order because you're multiplying. So like 3 times 5 is the same as 5 times 3. Is that okay? Okay. So when I do this, I get this number. But that's not C, okay? And it shouldn't be C. It doesn't make sense for me to get 101 when the other sides are 15 and 18, and it's only across from a 34-degree angle. That just doesn't make sense, okay? But that's because that's C squared. So what do I need to do to figure out what C is? Square root it, okay? Remember, technically when we solve algebraic stuff and we square root both sides, there's a plus and a minus aspect here. But I'm going to completely almost ignore the fact that there could be a negative solution to this equation because C is supposed to represent a side length that wouldn't be represented negative, okay? So I will take the square root of this and get 10.1 essentially. Okay. That makes more sense with the triangle, right? It's closer to 15 and 18. It makes sense that it might be the smallest side because it is across from a fairly small angle. Okay. So this is like the most straightforward type of question that you would get about using the law of cosines because they basically handed you all of the information that goes on one side of the equation to just calculate what would end up on the other side. Okay. All right. Can I change it? Any objections? No? All right. So now the directions say solve, which mean I'm finding everything about the triangle, okay? Is there a triangle? Is there a triangle? Yes, okay? Because, again, it's like that side angle side situation based on the setup. So I'm just going to draw a generic triangle. It's probably not right, but at least I have a picture. So I have a 47-degree angle A, 22 side length B, and 27 side length C. Okay. Once I decide there's a triangle, honestly, law of sines is my preference. It's a lot easier than the formula we just learned for law of cosines, right? But in situations like this, do I have a setup for law of sines? No, because I don't have that angle and the side across from it. So that's what's causing me a problem. It's like I want that to use the law of sines, but I don't want it because I hate doing the analysis at the beginning of that, right, to even decide if there's a triangle. So now I'm going to go ahead and use law of cosines. What angle do we want to use in our formula? It's probably the best way to approach it each time. A, okay? And sometimes you're solving for an angle. Okay, like in this one that I put up on the board over here, we'll talk about that one in a minute. We would solve for an angle. But so I'm looking for angle A, I have angle A, so I really want to use the cosine of 47, which means side length A would be on the other side of my equation, okay, which means side B and side C are the ones I would use in this calculation. Okay. So in that case, it's 22 and 27. Sorry. Keep not leaving myself enough room. All right. Super ugly. Sorry, can't read it. They're all 22s and 27s. So I'm going to do 22 squared plus 27 squared minus 2 times 22 times 27 times the cosine of 47. And I'm going to get 402.78595. Okay. But then again, I'm going to square root that. Okay, that number should seem a little bit high. Minus 2 times 22 times 27. Sorry, I didn't leave myself enough space when I wrote my cosine. So the formula always has 2 here, and then the 2 side lengths that you were using right there. Is that okay? And so I end up with 20.1 as side A. But the directions here weren't just to find side A. They were to solve the whole triangle. So I still need to find angle B and angle C. Luke? Yes. Now you can use the law of sines. Do you guys see what he recognized? I could keep doing some law of cosine stuff, okay? But I could just use the law of sines because now I do have an angle and a side across from it, okay? So I would be able to set up the sine of 47 over 20.1 equals, yeah, so we have to be a little bit careful here. Do you guys remember that every time in the last calculations when we were solving for an angle and we did inverse sine, like when there was two triangles and we had one that was obtuse and one that was acute, every time we solved the problem and we did inverse sine at the end, did it ever give us the obtuse angle? Think about the situations that we did yesterday when we went over your homework and we're solving two triangles. It always gives us the acute angle, right? There's a way that the calculator does the calculation where it limits itself. When you take the inverse sine of something, there's actually two answers every time, okay? There's an acute angle and there's an obtuse angle. But the calculator will always give you the acute angle, okay? Which means I shouldn't randomly pick which angle I'm solving here for. I should make sure that if there is an obtuse angle, I don't pick that one because I know my calculator won't give me the obtuse value. Does that make sense to everybody? So I have to choose right now whether I'm going to solve for angle C or angle B. I don't know if there is an obtuse angle in this triangle or not. But if there was an obtuse angle in this triangle, which angle would it end up being? Okay, so don't look at the way I drew it. Look at the numbers, okay? It would be C, okay? Because biggest angles have to have across from them the biggest sides, okay? So basically, I want to save the biggest for last, kind of thing, like save the best for last or whatever, right? Save the biggest for last, okay? Because I know my calculator won't give it to me. Now, maybe it doesn't matter, because maybe this isn't obtuse anyways. But I don't know yet, and I know the calculator won't give me the obtuse number when I use the inverse sine. So to be safe and to get the problem correct, I will always choose to solve for smaller angles before bigger ones in this situation. Is that okay with everybody? So you might want to make a note for that, okay? Solve for the biggest angle last, okay? Because your calculator is not going to give you an obtuse angle. And it might not matter. Half the time it will matter and half the time it won't, right? Just depending on the triangle. So when I go to set this up, okay, I'm going to save the biggest angle for last. So I'm only looking for either angle B or angle C. If I'm saving the biggest one for last, which one am I calculating right now? Sine of B. Good. And then I would put that over 22. So I'm kind of making a random decision, but not really, right? Because my calculator has some limitations on what it will calculate. So then I'm going to go ahead and multiply both sides by 22. Okay, and this is going to give me a decimal that the sine of B is equal to. And then I'm going to take the inverse sine of that to find angle B. And that's why I chose to look for B right now and not C. Okay, so angle B is equal to 53.2. So I put that in. And so now how do I find angle C? I don't go use the law of sines. Yeah, I just add them up and subtract from 180. Okay, so 53.2 plus 47 and subtract it from 180, 79.8. So would it have mattered if I used angle C instead of angle B when I solved? No, the calculator would have given me the right answer. But do I want to get in a good habit that I get it all the time, whether the angle's obtuse or not? Yes. So do not solve for the biggest one using the law of sines. If that's what you need to do, you save that one till the end and you just add and subtract to figure out what it is. Okay? All right. So a more complicated formula, but I'll tell you guys this on our quiz next week. I will let you guys use an index card with formulas on it. Okay? So you can write the formulas down. Is that all right? I don't want it to be an exercise in memorizing formulas. I want to see if you can use the formulas to actually solve the stuff. Okay?